All right. So how are we feeling about solving equations that are rational or inequalities that are rational? You know what? I don't even think I need this. I don't. So let me get rid of this. So if I were to give you something like and just for the record, there's probably no way this is actually going to work out nicely without the quadratic formula, but I can still show you the process to kind of get you started. It's just randomly making one up off the top of my head is not going to probably factor nicely. But if you were doing this because it is an equation or an inequality, what are you allowed to do here that you couldn't do if the equation part was gone?
Multiply through.
I can multiply through by what would have been your LCM of the denominators, right? And what would that LCM be? 12. And again, I told you I would take the time. Listen, we're talking about fractions of seconds. You can multiply both sides by a 12. And then because that's a number, I can distribute it in to each part. And then remember, I see people all the time that write 12x squared over 4. Minus 36x over 3, plus 60 over 2. Why did I multiply by 12?
So you could get it on the
To
bottom.
cancel the fraction, so cancel them, right? So cancel that. And be careful about your canceling, so you don't make a careless error. And that gives you 3x squared minus 4 times 2x is 8x equals 30. And at this point, what would I do to solve?
Bring that 30 over.
So I would subtract 30 over, right? And then I would try to start factoring this thing. And it probably does not factor because I just made this up. So for me, if it didn't factor, maybe it does, I'm just not. No, I don't think it does. I don't think it does. But I could always use the quadratic formula, which we technically haven't talked about, but you learned, right? Opposite. Right. So you've learned this. I could use the quadratic formula to solve it, but if you are seeing problems on your test, you're not going to need the quadratic formula. So what happens if you get down to this point and you see something that doesn't factor? Do you cuss me for lying to you and giving you a problem that needs the quadratic formula, or?
Said prime.
No. What's going to happen? What does that mean on a test? Think logically. I'm not going to do this to you. So if it happens to you,
you're wrong.
You made a mistake, right? You probably made a careless error. Maybe you went and you added a 30 instead of subtracting a 30. Maybe you said 4 times 2 is 6. I don't know. Maybe you forgot to distribute a negative in if that was necessary. But it's going to factor nicely if you do it right, so just go back and find that issue. Now, after doing this, for some reason, after we cover these two sections, and the one today is going to be very similar to this. The only difference is I'm going to put x's in the denominator.
Oh, fun.
But what changes if it's not an equation? Are you allowed to multiply both sides? No, why not? Because there isn't another side. So if you come in here now and go, oh, common denominator is 12, I'm just going to multiply through by 12. You can't do that. If I could randomly, this is not an equation that I can keep balanced, right? It's an expression which stands for a number. If I just randomly walk up and multiply by a number by something, I change its value, right? So now it's bigger. Well, I've changed it. I'm not allowed to do that. If I could just multiply by numbers, where would I go?
Bank.
I'd go to the bank. And why am I allowed to do it with equations then? Because I'm changing the values of the equations.
On both sides.
On both sides, so I'm keeping it balanced. Equations are about balance. Expressions about keeping its value. So don't just multiply by 12. What do? How do you add these? How do you add fractions? You learned this like in 4th or 5th grade. You're having a brain fart here. How do you add fractions?
It's the same.
Find a common denominator. So if you don't have an equation, guys, It's so hard for people, they know that walking in. I give them two fractions. How do you add these? Common denominator. And then I show you that rule about multiplying both sides, and it's like common denominator out the window. Everything vanishes. Your test is going to have both of these concepts on there, right? The part at the beginning and the part at the end. So make sure you find that common denominator. If it's 12, make the bottom 12 and adjust the top accordingly. Make the bottom 12 and adjust the top accordingly. So you end up with the same looking numerator, but you still have this. And I can't get rid of that denominator here. I don't have, this is the same thing as that. It just looks different. On an equation, you're changing it, but it's okay because you're also changing its balance on the other side. It's allowed that way. Right? Yes? I've probably never emphasized that enough. I'm really hoping that pays dividends. Because on your test, remember, we're going back and covering the early stuff. You've got, some of them are going to be equations, some of them are going to be expressions. Make sure you notice that. It's a massive deal. All right, so here's what we're going to be doing today. You tell me what's the difference between a problem like we initially did and then this. So again, I'm going to say solve. Again, I'm going to have fractions. Any ideas?
Factor the denominator?
Factor that just to see what we have. Okay, so that factors into x minus 5, 2, right? X minus 5, x minus 2. Okay, so I have 3 over that, plus 2 over 1, I guess, and then that over that. And I'm asking you to solve. I want to solve for x.
So that's the GCF, or that's the LCM.
So what is your LCM here? The highest power of every factor. So 1x minus 5, 1x minus 2, right? 1x minus 5, 1x minus 2, and I guess a 1. So I could rewrite each of these. I could put an x minus 5, x minus 2 on the top and the bottom. I could put an x minus 2 on the top and the bottom, and I'd have common denominators. But I don't want to do that on an equation, right? On an equation, what gift do I have? I can multiply through. So I'm going to multiply the left by x minus 5, x minus 2. And I'm going to, actually, I'm sorry, the whole left would be all of that. And I'm going to multiply the right by that. But because that's a number or an expression, I'm going to distribute it in to both parts. So it ends up being here, and I'm going to put it up here just to kind of show it. Now again, don't FOIL this out and multiply a 3 in. Don't multiply the 2 into that. Don't try to multiply that out. Why did you do this in the first place? To cancel out denominators? Because I'm allowed to do that on an equation, right? What cancels here?
All of it.
All of that, right? And all of that, leaving me just a 3. What cancels here? Nothing. Bring down the 2, the x minus 5, and the x minus 2. What cancels here?
X minus 5.
Bring down the x minus 4 and the x minus 2. And at this point, it just becomes a big FOIL fest and some algebra work, right? So what would you do here?
Distribute 2x.
So maybe multiply that together. That gives me back to where I was. And then distribute that 2 in. And make sure if there's a negative, you distribute the negative in also. Be careful about the little details. And then here, I'm going to have to FOIL all that out. Minus 2x minus 4x is negative 6x, and then finally a positive 8. And then what is my rule? See, now we're back in chapter 4 again. Solving polynomials. What's our goal now?
Set it equal to 0.
Set it equal to 0. So all of that's going to get subtracted over here. So when I subtract an x squared, that gives me an x squared. When I add a 6x, that gives me a negative 8x. And when I take this 23 and subtract an 8, I get a 15. And then what should happen here if you've done everything correctly?
It should be factor.
And sure enough, yeah, x minus 5, x minus 3. Now here's the new part. X is 5, x is 3. And if you write that, I got you. Now you've done nothing wrong mathematically at this point. except you failed to think about one small thing. And we talked about it earlier in this chapter, and we also talked about it at the beginning of the year, and that was domain. If you look up at this original problem, are there any numbers that are not in the domain? And do you remember how you check domain? You were concerned with getting 0 in the denominator, and you were concerned with getting negatives under radicals. Those are both bad things, right? Now we don't have a radical, so I don't have to worry about that. But is there a chance in the original problem that there's an x value that I could plug in and get 0 in the denominator? Because that's undefined.
Yes.
So x equals 5 would be bad, and x equal 2 would be bad. And you got to notice that. Did you have to worry about that on the last section? Because there were no x's in the denominator. There were no domain issues. But here you can see x can't be 2 or 5. So when you solve and see that one of the answers is 5, but you're not allowed to have a 5, then you've got to toss that and go with just the 3. Don't do all this great work and then not check your answers. All right? And again, if there weren't variables in the denominator, you didn't have to worry about domain because you don't have any domain issues. All right, what about this? So if I gave you this, what would you do?
Factor the x squared minus x minus 6.
So you would factor that out. So let's just say that factors into x minus 3, x plus 2. Now what?
Well, that's
Find an LCM. And your LCM would be highest power of each factor, so x minus 3, x plus 2. What are you going to do with that now?
Multiply.
Don't actually do anything.
I'm not going to do that. Wait.
Can you multiply through by an x minus 3, x plus 2?
No.
No, because this is not an equation, right? If this has some value. I don't know what it is because I know what x is. But if I did, like if x was 10, that would mean that was 12 times 7. That'd be 84. Right? So if I just multiply by x minus 3, x plus 4, x plus 2, I could be multiplying by a number. Changing the value. So in this case, to avoid that, what would I have to do if I wanted to add these two together? Find a common denominator, and I did. And then just make that be this common denominator by multiplying the top and the bottom by an x plus 2. But don't do that, because that's not the equation I want to solve. I actually want to solve this. So now that I actually have an equation that I'm asking you, or actually an inequation, an inequality, what do?
Same thing in the first.
So same kind of thing?
Yeah.
Is it still the LCM still this times this?
Yep.
Yeah.
Okay, so I'm going to multiply the left, which is all of that, by an x minus 3, x plus 2, and it's going to distribute into each part. And I'm going to multiply the right by an x minus 3, x plus 2. And then again, why did I do this?
To cancel stuff.
To cancel stuff. So don't start foiling it out. Cancel stuff first. Bring down the x squared and the x plus 2. And I gotta be honest with you, people that bring it down and don't try to multiply too much in their head, save them this mistake. Like right here, well actually it wouldn't have mattered here. Both of those cancel. Bring down a positive 4x. But sometimes right here, when that's a negative that I'm pointing at, sometimes when people multiply the junk out up here and bring it down and then drop the negative, they forget to distribute it. But in this case, it wouldn't have mattered, obviously, because it's positive. But I usually just bring everything down, then I do the math down here. Takes me an extra 2 seconds, and I cut back on my errors. And then over here, oh, what happens here? Is it still a greater than? Or is it changed to a less than? Or do I not know? What's going on?
It flips. No.
What did I just multiply by? A positive or negative number?
Positive.
Really?
Well, don't you just say?
No, they did a negative, so it'd be flip.
We've done this, right? We said before, we don't know. Like, what if x is 0? If x is 0, then I'm multiplying by 2 by negative 3. That's negative 6. I would have to change the sign. What if x is 10? Well, if x is 10, I'm multiplying by 7 times 12. That's 84. That's a positive number. Don't change it. What if x is negative 20? Then I'm multiplying by negative 23 times a negative 18, which is a huge positive number. Don't change it. Sometimes I do change it, sometimes I don't change it. Well, I don't know then. So I'm gonna leave this. I do know it's still equal. And if there wasn't an equal, I would put not equal. But I don't know about the inequality anymore, and I don't care. Because I just want to solve this. Here, this cancels. And I'm going to find my critical numbers. Now, we did this before in the last chapter. But I started you here. And there was an inequality sign. We didn't do a ton of it, because most of the time, like if you think about the last test, the last two problems are already factored up for you. Set equal to 0 and factored. And we marked them on a number line, didn't we? And then we just checked in between them. We're going to do the same thing with a little bit of a change. So how do I figure out where these things are equal to 0? Multiply it out. Yeah, solve it. Distribute that. I get x cubed plus 2x squared plus 4x. This gives me 3x squared plus 6x. Move it all over here, and I get x cubed minus x squared minus 2x. So at this point, can you continue to solve?
Yes.
Factor out an x. Continue to factor. Hopefully we can factor. And I get 0, 2, and negative 1. But wait, if all I do on my test is come here now and mark the negative 1, the 0, and the 2, and check in between them, I'm omitting one major concept.
Domain.
The domain. It's not equal to 3, x can't be 3, and it can't be negative 2. So in addition to these three places where it is 0, I've got to mark a negative 2 as it does not exist, and a 3 as it does not exist. Open circles, and now I've got to check a couple of extra spaces as well. So that's a lot of checking, but can you actually check it?
Yes.
And where should I check it? In this? No. Where? In the original problem, which is a mess, which means if I were to give you one like this, it would be significantly more tolerable. And I'm also probably going to make these so you don't have to plug in stuff like negative 1.5 in there, because that's going to be truly a mess. But this is totally a Vestavia-like question. So let me just show you a couple of checks. Yeah, Vestavia doesn't mind at all giving you this kind of junk. Let's just see if we have any true places or not. So let's just randomly pick something. How about, this is easy, let's check 1. So if I plug 1 in here, I get 1 over a negative 2. So I'm checking 1 here. I get 1 over negative 2 is negative 1/2. If I plug a 1 in there, I get 4 over, and you can plug it in that equation or its factored part. Negative 2 times 3 is negative 6, or you can plug it in there, negative 6. So 4 over negative 6, negative 2/3. If I plug a 1 in there, I get 3 over negative 2, negative 3/2. So, is that bigger than that? Well, I can kind of eyeball it and go, you know what, a negative 0.6-ish and a negative 0.5 is a negative 1.1, and that's a negative 1.5. So even without, does that make sense what I just did?
Yes.
So even without a common denominator, I can see that this is bigger than a negative 1.5. It's closer to 0, right? So that's true. I can come in here and check that. I mean, I can come in here and shade that. But if I wasn't comfortable, find a common denominator. And I get negative 3, negative 4, negative 7, 6. Is that bigger than this? Oh, and if you're still not sure, find a common denominator here. Is negative 7 over 6 bigger than negative 9 over 6? Yeah, negative 7 is bigger than negative 9. So if you need to find common denominators all the way through to C, knock yourself out. And you're going to keep checking and checking and checking, and eventually you get this. But again, if you're looking at that and going, how am I going to get finished in time? You just gotta be diligent and careful. And if you got down to here and then didn't get it shaded, you're not gonna lose a lot of credit because you've done the heavy lifting. So your final answer ends up being from -2 to -1 bracket on the -1, bracket on the 0, bracket on the 2, open on the 3, all the way to infinity. Comma, comma, or union. So pretty ugly, but it's not like you're gonna get a dozen of these. At most you have one, and again, if I were to give you one, I'm gonna space these numbers out so you can at least check whole numbers when you're checking, and you don't have to go, okay, fun, let's plug -3/2 in here. That looks like just a nightmare. I'm not gonna make it about that. Are y'all with me? And honestly, again, if you got everything on this number line, if you remembered the undefined spots, if you solved for this part correctly, and you got down to here and made a mess of it, you'd probably be looking at worst case scenario of that. It's not gonna cost you hugely. Track with me? Okay, all right, so here's what I wanna throw you a couple word problems, see if you're with me. And it's gonna be basically this kind of stuff. And I'll point out why these word problems are showing up now. But hopefully it won't be too terrible. Don't get intimidated. Okay, I know every time I say distance, rate, and time, there's some of you that like a cold chill goes up your spine. It's like, oh my gosh, no. Don't be intimidated, just be logical. Let's see what happens. Okay, so what if I told you this? What if I told you, I should have this typed out, but because of strong headwinds, an airplane's ground speed for the first half of a trip is, the first half of a 2,000-mile trip is 600 miles per hour. What must its ground speed be for the second half of the trip if the plane averages 720 miles an hour for the entire trip? So as you're copying that down, if you're copying it down, we'll walk through it again. So evidently there's this 2,000-mile trip this plane's going on, and for the first half of the trip, okay, so the first half, and they're talking about first half, they're talking about the distance, not the first half of the time. So like for the first, like you could say 1,000 miles of a 2,000-mile trip, the plane was going 600 miles an hour. And then it said, I didn't know anything about the speed for the second part, but I know I ended up averaging 720. Now, the big mistake somebody could make was, oh, if I'm averaging 720, and this one's 120 miles per hour below, then the other part must have been 120 miles ahead, which should be 840. And that's the big mistake a lot of people make on this. And they get no credit because they didn't show any math, whatever, they're just trying to use common sense. That would be true if I had said this. For the first 5 hours of a trip, I went this fast. And then I averaged 720 miles an hour for the total 10 hours of the trip. If I do the same speed for the same amounts of time, like 40 miles an hour for an hour, 60 miles per hour for an hour, it is the half mark, is the average. It would be 50 miles per hour for the total, but not if it's distance. I mean, think about it. Like if you run track, I know you've run these hills, right? Right? It's pretty tough running up those hills. But I guarantee you, if somebody said, I'm going to clock you on the way up and clock you on the way down, you could probably run on the way down faster. Unless you've got bad knees or something like that, I don't know. But you can definitely go down faster. So what's happening here is they're basically saying for the first half, I was going definitely slower, but the distances were the same, not the same amounts of time. Now, when you hear distance, rate, and time, what should pop into your head? I've told you, when I hear distance, rate, and time, I always write these three things down. Every time.
Distance equals rate time.
That's the first one. Distance equals rate times time. And that pops into my head because it's like burned in your brain. But if that's true, isn't also T equal D over R and R equal D over T also true? I mean, really, aren't you right? But that's the first thing that pops in my head. And then what else did I tell you popped into my head? I said I always write these things down and then try to figure out how stuff works into that. Didn't I tell y'all that total distance equals first distance plus second distance, and total time equals first time plus second time? Remember that? And then, if I really need to, I can replace these D values, if I don't know them, with our T values. I can replace these T values with D over R values, if I need to, because they're equal, right? So let's go back and look. What do I know here? I know the first rate looks like 600 miles per hour. First rate is 600. Okay, so right here, I don't know D1. Actually, I do know D1. D1's 1,000. But if I plug 1,000 there, and 1,000 there, and 2,000 there, I don't really get anywhere in terms of solving this, do I? I'm very comfortable with 2,000 equals 2,000, but not a lot of luck there. So maybe it might be better to go, hey, D1 is RT. And D2 is RT. But the problem with that is, I'm kind of stuck at this point. Are you following me? Because I don't know either of the times, and I don't know the second rate. And I certainly don't know the average rate. So kind of stuck. All right, well, let's say that doesn't work for me then. I also know, I don't know the second rate, but I do know the average rate, the weighted average anyway, for the whole trip. And then, of course, I know all the distances, right? Well, what about this? If I didn't get anywhere with that, what about this? What is total time got to equal to? Or T1 or T2, what do they got to equal to? That? So total time would be total distance over average rate. T1 would be first distance over first rate. T2 would be second distance over second rate. Well, man, I got all kinds of stuff now. I know the total distance. The total distance is 2,000. I know the first distance is 1,000. And the second distance is 1,000. I know the average rate they said was 720. The first rate was 600. And I was looking for the second rate. Well, you know, that's money. I got everything I needed, and quite honestly, doesn't it look like something we're doing in this chapter? But to make it a little better, those fractions are pretty big, right? Pretty big numbers. Can I clean it up before I get started?
Yeah.
Like, what's 1,000 over 600? You divide a 0 out, another 0 out, and 10/6 is,
5/3.
that's going to make finding a common denominator much more clean. What about here? I can divide a 10 out of the top and the bottom. I could divide a 4 into that,
5/18.
a 4 into that. Actually, I could have divided another 2, right? So I could divide an 8 into that and an 8 into that. 25/9. And if you do that, now the common denominator is not so bad. So what, should I find a common denominator of 9R? Or should I multiply through by a common denominator of 9R?
Multiply through.
I'm going multiply through. And I'm distributing it in. And the 9 cancels here, leaving me a 25 and an R. Technically an R2, but I think we all know that. And then here a 3 cancels, leaving me a 15 R2. And here an R2 cancels, leaving me a 9,000.
They subtract.
And I subtract, and I get 10 R2 is 9,000. And here, when I divide by a 10, I don't even have to factor. 900 miles an hour. And was there an R value that wasn't allowed, that was not in the domain? What could R not be here? Couldn't be a 0, but that hardly affects me, right? So if I didn't even mention that, it's not a big deal. Or sometimes it can sneak in on you. Now, did I tell you anything else about solving for for rates? It's the end of a lesson, maybe the end of a video. I threw it out there real quickly.
2 times.
I said the average rate was what, Lily?
2 times R1 divided by 2 over R1 plus R2.
I said 2 times the product of the rates over the sum of the rates was the average rate if what?
The distance.
The distances were the same, and the distances are the same, right? So I could have grabbed this equation. It wouldn't have been exactly what we're doing in this chapter, but couldn't I have said, wait, average rate's 720. First rate is 600. I don't know the second rate. First rate is 600. I don't know the second rate. Couldn't I have just plugged it in and then just cross multiplied? Check it out. Cross multiplying gives me 6 times that. 3 zeros, it's a big number. 432,000 plus 720 R2 equals 1200 R2. Subtract the 720, leaves me 480 R2. And then when I divide by a 480, $900. But that only works if what? The distance of the first and the distance of the second part were the same. That usually happens when you're like going over there and back. But it could also be like during different steps if it was the same distance. Like if it was the same, 600 miles from here to Dallas and then another 600 miles from Dallas to Denver or whatever, if that was true, which is close, but I don't think it's exactly true. But if it was by plane, then you could do an average rate problem this way. Although most of the time we know the 2 rates and we're finding average rate. That's a classic little math thing question. This one you knew the average and not the second, so you had 2 variables you had to cross multiply to get them together. Y'all tracking with me? All right, what about this? Remember the pump question?
Yes.
Yes? What did we do what did I talk about? My other class, I don't know if y'all were here for that. Were y'all here? Is that y'all when we talked about pumps in class, or were y'all watching the video? Seems like y'all watching the video. But they were like, oh my gosh, it makes so much more sense when we think about it, when I give you hours, to not think about it as hours, but think of it as a rate. So if I told you something like, hey, pump A pumps it out in 30 hours, pumps out the boat in 30 hours, to think of it, instead of like, that's the time it took him, think he's doing 1/30th, or that pump is doing 1/30th of the boat per hour. So if you think about it as a rate, now you got like a rate times time problem. It's kind of like a distance problem, but it's more of an amount problem. Well, right here, think again like that. I'm going to have some total amount, and then I'm going to have some rate times time, plus some rate times time. Okay? So I'm going to read this problem to you. You tell me if you can place everything. Ken can clean the house in 20 hours. Barbie and Ken can clean the house in 7 hours if they work together. How long would it take Barbie working alone? How long would it take Barbie working alone? Let's think. Do I know how many houses they're cleaning? The total amount?
Yeah.
I guess just one house. They didn't mention any otherwise. It said a house. Now, let's just say this stands for Ken's and this stands for Barbie's individual information. Now, if Ken can clean the whole house in 20 hours, what was his rate?
1/20th.
1/20th per hour. So his rate would be 1/20th for each unit of time he spends. Now, what is Barbie's rate?
T20 minus.
I just don't know. It didn't mention anything about what Barbie's rate was, because that's what it's asking for. How long would it take Barbie working alone? I don't know that. Do I? I could just plug a big R in there, I guess, but I'm gonna look at it like it's 1 over X. Because I wanna know how many hours it took her working alone, so I'm gonna use 1 over X to be her rate, so I can determine how many hours it would take her working alone. But they worked together this time. So this time, when they do work together, it's 7 hours. Now, if you think back to the last question, I was looking for how many hours, right? So I was solving for T here. You with me? I was solving for T on the questions before. But now I know, I was saying basically, how much time does it take them working together? And you put a T in there and you solve for the time of them working together. But now I know that time. It's what?
7 hours.
So I know the 7. So essentially what I'm dealing with here is 1 equals 7/20 plus 7 over X. And that's why this is in this section. It's basically a fractional or rational equation with a variable in the denominator. So what would you multiply through by?
20.
A 20x. And you can do that because it's an equation. And when I distribute that 20x in, nothing cancels on the left. The 20s cancel, leaving me a 7x, and the x's cancel, leaving me a 140. And when I solve, I get an ugly fraction. But if I was asking it, and we were trying to make the most sense of this, how many hours is this? Right? So 10 and 10/13 hours. But if I wanted it in hours and minutes, how do I take 10/13 hours and change it to minutes? What do I do with that 10/13? Multiply by 60. Hey. Yeah, that class. Yes. Okay. All right, bye. So multiply by 60. So I'm going to take that 10/13. I already know it's going to be 10 hours. I'm going to take the 10/13, multiply by 60. I get 600/13. Very annoying, I understand. But if I need to be accurate to the minutes, I go in there 52, 678. So I got 10, 46, and then 2/13 minutes. But if I want to be accurate to the nearest minutes, wouldn't I have rounded that down?
Yeah.
And if I want to take that portion of a minute and figure out how many seconds, what would you do? Multiply 60 again and keep going. And if you did that, blah, 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 you get 9.2 seconds if you really cared. But you would have to take that and multiply by 60 again to get this. But I would probably say round to the nearest minute. So, you with me?
How do you write the seconds? And then you did like the 10:46, and then you do like.
I think you put another colon,
Yeah.
and then the second part. All right. All right. That's all I got. Feel like you're with me?
Yep.
I got one more thing tomorrow. No, we're reviewing. No, we got one more thing tomorrow, and then review on Thursday. Yes, that's right. Oh, actually, I take that back. That's it. I'm giving you 2 review days.
Sweet.
All right, I'm giving you, there are 2 reviews in the book. You're doing review number 1 tomorrow when you're not here. You're doing review number 2 as a class, and everybody comes back on Thursday, and then we'll test on Friday. All right? And then after that, it's no more Wednesdays. Just full time unless you are queued up.
Are we gonna have a video tomorrow?
Yes, actually, I don't know. I might if I have a bunch of questions, but if everybody's staring at me blankly, then I don't know. Definitely check. I might just kind of randomly pop through a few questions on the review number 1.